Hello everyone, I am Vaishnavi from Tegala Krishna Reddy Engineering College, studying in Electrical and Electronical Engineering Department. Today I am going to present on time domain control algorithms of DSTATCOM in a three-phase three-wire distribution system. We are going to publish this paper on International Conference on Intelligence Data Communication Technologies and Internet of Things. And our paper ID is IDC IoT 586. This is our abstract. In this paper, a crystal clear explanation is seen regarding improvement in a power quality distribution system. When the electrical power systems appear to be out of phase, that is either unbalance of power on the source side or load side, irrespective of any case, we use FAC devices. FACS is nothing more than a program that uses electronic controllers to boost the effectiveness of current power systems. Over the past few years, research on new developing technologies has also been ongoing. STATCOM is one of the most important FACT controller device. It is connected shunt. So it is also called as shunt connected FACS device. Overall cost point of view, we go for VSI, that is voltage source inverter. DSTATCOM is nothing but distribution static compensator, is placed at PCC, that is point of common coupling, to solve the above problem, which is to get into the phase of currents and voltages. A DSTATCOM has different theories to explain the performance. But here we explore two of them. Those are SRFT, synchronous reference frame theory, and IRPT, instantaneous reactive power theory. After processing, we simulated the results in MATLAB Simulink. As we all know, today nonlinear loads are increasing day by day. So in the nonlinear loads, there are harmonics present. To eliminate these harmonics, we use filters. As we all know, there are two types of filters, active filters and passive filters. We are going to explain the shunt active filters. The performance can be based on the control algorithms which we use. Coming to introduction, our primary goal is to provide consumers with quality power. This is possible when we use FACT devices. The FACT device can be connected in three different ways, that is shunt, series, and shunt series. STATCOM is the name of the FACT device that is connected in shunt. A static compensator, also known as a voltage source converter or current source converter, is an electronic device that controls power using IGBTs, MOSFETs, and other devices, etc. The main function of DSTATCOM is to generate or absorb the reactive power present at PCC. So that power quality issue can be eliminated successfully. So before solving the power quality problems, it is better to know what are these power quality issues. The following are few power quality issues that I am aware of. Disruptions in power frequencies, transients in power system, harmonics in power system. First very topic which I am going to explain is three-phase three-wire distribution for DSTATCOM. There are three-phase four-wire distributions also, but I am going to give an explanation on three-phase three-wire distribution. The three-phase three-wire distribution system is used for the compensation of consumer loads and also improves the power quality of the system. As we all know, the supply is from generating station where electrical power is generated and transmitted over long distances to reach the distribution station. From this distribution station, loads are connected to satisfy the consumer needs. Here in daily life, we observe nonlinear loads, as I have explained, are more compared to linear loads. There will be a disturbance in the distribution sector. To overcome these unbalanced disturbances, we are going to introduce FACS devices, which are DSTATCOM, which are very useful for balancing these problems. This is control scheme. The figure shows the control technique used for our DSTATCOM. There are different kinds of control algorithms used for the implementation of DSTATCOM, which are classified into two categories. The main categories are time domain and frequency domain. In this, we are going to explain about time domain control algorithms. The two categories mentioned above are further divided into numerous types. We examine the two basic kinds of time domain control algorithms, mainly SRF and IRP. Instantaneous reactive power theory. The IPR theory is based on a set of instantaneous powers defined in the time domain. It can be applied to three-phase system with or without a neutral wire for three-phase voltage and current waveforms. This theory is very efficient and flexible in designing controllers for power conditioners based on power electronic devices. From this figure, we can know that there is a Clark transformation, which is nothing but ABC to alpha beta, which transforms ABC, that may be voltage or current. It can be transformed into two phase, that is alpha beta, V alpha or V beta, or else I alpha or I beta. With the help of formulas, we can calculate the power, real and reactive power. By using filters, we can eliminate the harmonics present there, and it can be converted to three phase to generate pulses with the help of inverse Clark transformation. This is all about instantaneous reactive power theory. Next is synchronous reference frame theory. In this diagram, we use phase local loop, PLL, in closed loop control systems to log the input and output frequencies with some constant phase error. In both instantaneous reactive power theory and synchronous reference frame theory, we go for Clark and Park transformations. With the help of Clark and Park transformations, the ABC load, either voltage or current, can be converted into alpha beta. After converting it into alpha beta, we can also convert that alpha beta into DQ with the help of Park transformation. By using filters, we can eliminate the harmonics present there. And again, after getting the output from this DQ, we calculate the respective powers with the help of formulas. And after that, we will go for inverse Park transformation, which converts DQ to alpha beta. And after that, we go for alpha beta to ABC with the help of inverse Clark transformation. The next is input and output voltages and currents. Here, I'm going to show you the supply voltage and current as well as output voltages and currents. These are the figures we have simulated in MATLAB Simulink file. These are three-phase figures. We can observe the output and input waveforms obtained with the help of MATLAB and Simulink. Three-phase output current, three-phase input voltage. Figure 1 shows the three-phase output current with the x-axis time in seconds and y-axis output current. And figure 2 shows the three-phase input voltage, where x-axis it shows the time in seconds and y-axis it shows the voltage input. These are compensation outputs. Figure 3 shows the compensating current, where x-axis shows the time in seconds and y-axis shows the compensating current. Figure 4 shows the compensating voltage, where x-axis shows the time in seconds and y-axis shows the compensating voltage. The conclusion of our paper is this paper gave information or facts, that is shunt connector DSTATCOM for the power quality improvement, and explain different control algorithms of DSTATCOM like SRFT, synchronous reference frame theory, and IRPT, that is instantaneous reactive power theory. Additionally to the explanation, they also compared and their performance is investigated accordingly. Simultaneously, the results are simulated in MATLAB Simulink.